this video is meant to be a quick explanation of translations. So a translation is a transformation that moves all points of a figure called the pre-image in the same direction for the same distance. So when I describe a translation that I want you to make, I'll use two different methods. Sometimes I may use a word description. So for example, I might ask you to translate a figure to the right 3 and down 2. Or I might describe that same set of directions using something that looks like coordinates. So moving to the right 3 and down 2 would be described as adding 3 to the x coordinates and subtracting 2 from the y's, which would look like x plus 3 comma y minus 2. So in this example, we're starting with a rectangle called RECT. So that's our pre-image. And our directions are to translate using the coordinates x plus 2, comma, y minus 1. What that means is we're taking all of the original points and adding 2 to the x's. So notice here, the original x value of r was negative 2. If I add 2, I get 0. So same thing in E, the original x was negative 2. If I add 2, I get 0. In C, the 3 becomes a 5, and in T, the 3 again also becomes a 5. So then for the y values, the y minus 1 means that we are subtracting 1 from each of the y coordinates. So in point R, the negative 1 subtract 1 becomes negative 2, and that happens in point T also. And then for points E and C, their y values were 2, so when we subtract 1, we get positive 1. And then you can see in the graph on the right, that's what our new rectangle would look like. So the shape and the orientation look exactly the same. All that happened is we took that rectangle and slid it elsewhere on the graph. That's what a translation will look like. So on page 3, we have two problems to try. We need to graph QRS in number 6 first, and then we will use the translation to make a new image. So point Q is 2, 5, and I'll label that. Point R is 7, 1, and point S is negative 1, 2. So now when you're doing translations, it really doesn't matter if you draw the diagram first or write the coordinates first, but I will want both. So I'll do one of each method. So for number 6, what I'll do is I'll just use the directions to draw the new diagram, and then I'll use my diagram to write down the locations of the new points. So I'm just going to take each of the vertices, Q, R, S, and T, and move them left 1 and down 2. So if I start at point Q, if I go left 1 and then down 2, here's my new location for point Q, and I'm going to call that Q apostrophe. And I'm just going to keep going around the shape. So point R, if I move that left 1 and down 2, there's R apostrophe. And then point S, left 1 and down 2, and that's S apostrophe. And then I'll reconnect the points in the same order. So QS and QR get connected, and then RS gets connected. So there is the new location of triangle QRS. That is the image. So if I write down the coordinates, notice that the new value of point Q is at 1, 3. And if you compare that to the old point Q, it should look like the x decreased by 1 and the y decreased by 2. And I should notice the same changes made to each of the other points. So the new R apostrophe is 6, negative 1. So again, notice the x went down by 1 and the y went down by 2. And then for point S, its new location is negative 2, 0. So that again should look like the x decreased by 1 and the y decreased by 2. So in number 7, what I'll do is I will work with the points first and then I'll graph afterwards. But what I will do is I'll draw triangle AB, or I'll draw parallelogram ABCD first, just so we can see what that looks like. So here's point A, point B, point C, and point D. And I'll connect them around AB, B to C, C to D, and then D to A. So if I just work with those points, what I'm going to do for my new points is my directions are telling me here that I need to add 3 to the x's and subtract 2 from the y's. So if I take point A, adding 3 to its x value makes the 1 a 4, and subtracting 2 from the y makes the 6 a 4. So the new location of point A is going to be 4, 4. So that's A apostrophe. For point B, I'm going to add 3 to the x, so that makes the 4 a 7. And I'm going to subtract 2 from the y, so that makes the 5 a 3. So 7, 3 is the new B. Point C, add 3 to the x, so 1 becomes 4. Subtract 2 from the y, negative 1 changes to negative 3. So there's my C apostrophe. And then for point D, add 3 to the x, so negative 2 plus 3 is 1. Subtract 2 from the y, 0 minus 2 is negative 2. So 1, negative 2 should be the new D. And when I reconnect, all the translation does is it slides the whole shape somewhere else on the graph, so it should look like the same shape, but all it's done is it's moved elsewhere on the grid. I'm just going to erase my messy line there. So now we have translated parallelogram ABCD using the transformation x plus 3, comma, y minus 2.